All right, so welcome to Packet Capture 101. This is a talk about how to capture packets and some of the other things related to it. If you have captured packets before, then you will probably know a couple of things about this. But I thought I do an introductory class on this one just to cover some of the aspects of it. And we will also look at some of the trace files that result from packet captures, of course, to see what can possibly go wrong in some situations. So, my name is Jasper Bongertz. I'm from GData Advanced Analytics, and I am on Twitter at PickupNG. If you want to follow me or look what I'm doing, then continue. Okay, capturing packets. First of all, a quick look at capture file formats, because those are a little bit important. Then selecting a good location for captures. Preparing the capture device is something that I will cover in some additional hints, and I have some tips and hints in the process. So it's not like we're going through all of this in an agenda kind of style, so this is basically what you can expect during this talk. All right, so first of all, capture file formats. These are important because before you can analyze packets, you need to capture them or record them. And they are stored in files on disk usually. And there are different file formats that evolved over time. If you recently started with packet captures, you probably know that there's PCAP and PickupNG, PickupNG being the default format Wireshark uses. But there have been earlier ones. Sniffer, for example, which was one of the first commercial analyzers, used the .enc format, which is in its simplicity quite similar to PCAP. And then there was a much more complicated .cap format. .enc is documented quite well, I think, and .cap isn't. So in the .cap there are some funny bytes and bits in there that nobody knows what they do. And I assume that even those who created it don't know anymore. So yeah, if you are ever opening a .cap sniffer file, Wireshark can do it, but it can't read all of the details that are in there, so it skips them. Because they would need to be reverse engineered, and well, that is something that is not really useful because nobody uses that format anymore, I think, or few people do. And they don't care because they're just using the sniffer then, and it can read and write it, so it doesn't matter. The open formats are .pcap and .PickupNG, and we will take a closer look at those two. Important maybe, if somebody's talking about trace files, they mean capture files, and sometimes it's just called PCAP. So if you see somebody running around with a PCAP or it didn't matter hat, like we have back there, that is what is meant. Like, give me a trace file or give me proof in a file so that I can verify, or whatever you say isn't going to matter, right? That kind of phrase evolved when people were claiming dubious things. And some in the industry said, well, we need a PCAP, or whatever you say, we're not going to believe you. And I think there's a very prominent case in the US about some guy selling pillows who claimed he had a PCAP or some things and really didn't. So anyway. Important to know maybe is that most formats have at least two sections. They have a file header section that contains some information about the file in general, and then a list of packet header, packet data entries. So the packet that you capture on the wire is as it was on the wire, but there's some information that you need to add to it to store it correctly, because, for example, a packet on the wire doesn't know when it has been on the wire, right? So I'm sending a SYN packet, it travels across the wire, but the packet itself has no idea what the current time is. But I need to store the time with the packets, or otherwise I couldn't do any kind of timing analysis. So my header needs to contain additional information about the raw data in the packet, for example, the time. Yeah, we will take a look at this at the next slide. So the file header usually contains a file magic that is like a unique kind of string, so that if you open a file and you look at the first usually 6 to 8 bytes, then you will be able to tell, oh, this is a PCAP file or this is a PickupNG file. Yeah, PCAP file, if I remember correctly, starts with a hex sequence of A1, B2, C3, D4 in most cases. And PickupNG has a slightly different file magic, but that is the reason why many tools can open files without really knowing what format it is, because they just look at the file magic and they know, oh, this is PCAP. Right? So, not that important. Important is the link type. The link type tells the analyzer on which kind of medium this was captured. Nowadays, it is usually Ethernet. But back then we had things like token ring and some other, physical media, and you need to know which kind of format it was on the wire. So usually the link type has to be written down. And sometimes if you're capturing other things like USB commands or something like this, there will be a different link type in there. It won't be Ethernet, of course. Then there's the packet headers, and they usually contain a timestamp, very important, because we need to know at which time the packet was captured. And this timestamp is something where you can get nerd sniped really easily, as we learned from the Shark Bytes, because there's different timestamp formats and precisions. So sometimes timestamps are seconds, milliseconds, microseconds. Sometimes they even have nanoseconds. The problem about nanoseconds is that you need to have a very precise capture device to be even able to write it, because with a normal PC, like your laptops or any server, anything out there that uses standard hardware, you cannot go into the nanosecond precision. The cards are just not precise enough. So if you need nanosecond precision, you will need a special capture card, an FPGA-based capture card. There's a couple of vendors out there. Usually they cost a 4-digit number and higher, so you need to be really interested in capturing packets that way so that you spend that much money. So yeah, the timestamp is also something, if you ever write a piece of software that reads PCAP or any kind of capture file, this is where you're gonna lose a couple of nights sleep, because converting whatever is written in the file to something really readable is really complex sometimes. Okay, then the other thing that we need is the captured packet length. Captured packet length is important because you can decide that you don't want the whole packet. Yeah, very often you can say, I only need the headers, so I only capture the first, 128 bytes or something. And the analyzer needs to know how long was it for real. So it needs to store the captured length, which means in this file the packet will be, let's say, 128 bytes long. And that also means you need to know what's the original packet length. So it could be that you captured only 128 bytes, but the original packet was 1514 or 18, and those two values need to be in the headers for each packet. So I think this is the bare minimum that you need. Sometimes there are capture file formats out there that don't even have that kind of thing, so there are capture file formats without timestamps, but nobody really uses them. I've seen them once in a law enforcement environment, because they were just interested in the data and not when it happened, just that it happened, and it didn't have timestamps. But I think that is something we can ignore. So various formats store additional data, and that can be a lot of things. For example, we have a discussion, or had a discussion, I don't think it's in there yet, for PickupNG, that, for example, if you're capturing Wi-Fi, you could store the GPS coordinates of where you are right now. Yeah, which would be interesting, because if you're moving around with a laptop to see how good the Wi-Fi signal is, it would be interesting to know where's your physical location, not just the time. So this is something that you can store in some formats, but not all of them. Okay, so quick look at PCAP. It's the most common format, or it was at least the most common format, up until to the point that Wireshark changed the default to PickupNG. It was developed by Van Jacobson and Steve McCann in the process of when they created TCP dump. Steve McCann gave a keynote in 2010 at SharkFest, talking about how he created the BPF filtering engine, and in that fascinating talk, by the way, it's on YouTube and you should look at it if you have the time. He apologized for PCAP being a file format that he created in a hurry and it got out of his hands before he could finish it, which is something that I like to hear, because I think it has, well, it's really simple. You can really quickly write a code to read and write it, but it has some shortcomings. So yeah, there's people that like it and some that don't. If you want to take a look at it, Guy Harris has created a RFC for this, which is something I learned when I wrote those slides, because I didn't know there was an RFC, but now there is one. Okay, do I need to take a look at the chat for any questions? No? Okay, good. Then we have PickupNG. It's the default capture file format since Wireshark version 1.8. Actually, it was decided on SharkFest to switch from PCAP to PickupNG. I have to admit, I'm one of the people who probably are guilty for this, because when the discussion in the closing keynotes of SharkFest, I don't know when it was, came up, should we make PickupNG the default? I said, well, if Wireshark doesn't do it as a default, nobody will, so it will stay experimental forever. And I think Gerald kind of accepted that reasoning. So if you want to blame somebody for PickupNG being the default format, I'm right here, come at me. All right. It's much more flexible. It's using a block type structure that allows to store information in a much more versatile way. And we heard in the keynote of Zystic that they can store the information in PickupNG as well, even though it's not basically Ethernet packet data or any kind of packet data. That is because there's block types with numbers assigned to them, and if you read it, you will always look at the block and check which type is it, and then you know what's in there. I remember the time when Zystic decided to store it in PickupNG, and once again, Loris was asking like, hey, I need block types for PickupNG to store my Zystic messages. How can I do this? And I think I was the one that answered him, well, use block types 200 until 205 or something. So once again, I'm at fault for that kind of thing. So it has a section header block. That is basically what I talked about when I meant everything has a file header. There's an interface description block, because PickupNG is the first format that allows storing PCAPs taken on multiple interfaces at the same time. PCAP can't do that. PickupNG can, because it has interface blocks describing all the interfaces that you capture on, and it doesn't matter if it's Ethernet, token ring, USB, whatever, because every interface that you capture on will have an interface description block written into the file. And all the packets that are written in enhanced packet blocks, and they reference the interface that they are coming from, so that you can separate them again. Okay, I have a whole talk about file formats done at a previous SharkFest, so if you are interested in that kind of thing, you should find that on YouTube on the retrospective page. And if you want to read the specification, it's much longer than PCAP, and it's much more complex, but it's really fascinating. All right, so which file format is the best? Question to you. Which one would you use? PickupNG, PCAP? Louder? Anyone? PickupNG? Okay. I have a very generic answer to this one, and it is like, use the format that keeps as much data from the capture process as possible. So if you're on a sniffer, let's say one of these old bulky sniffer things, it's probably better to use CAP because it will store more values about what was going on at the time of the capture. If you're using PickupNG, it will lose some of that information. So my usual answer is use the one format that keeps the most of the metadata with the file. You can always convert later using edit cap, but you're right, in most situations that means PickupNG, of course. Yeah, because it will keep most of the information intact. All right, so the next thing is select the capture location. That is the one thing that you usually need to figure out. Where am I going to capture the packets? Because if you capture, for example, on a link that the packets you need to analyze don't ever go through, that's kind of useless. So you need to select the spot where will I see the packets. And the discussion usually is close to the client, close to the server, or somewhere in the middle. And that depends a bit on what kind of problem you're having. For example, if you're having a problem with the server and many clients are experiencing difficulties, then it could be the best spot to capture at the server. But that could also mean that your server is connected with a 10 gig interface and you don't have any capability to capture a 10 gig interface. So maybe you should move to a client then, because it only has a 1 gig interface. So you need to take a look at what physical limitations there are and then select your capture spot. Things to consider are, yeah, of course, where did they travel past? What capture precision do you need? You can capture packets in a number of ways and we will look at them. But the question is, how precise does it need to be? There's some that are way more precise than others, but the more precision you need, the more complex it gets to set it up. And you need more material in a lot of situations. So that's something that needs to be considered as well. And then again, what limitations exist? For example, if I want to capture, let's say, a virtual machine in an Amazon data center, I kind of doubt that they let me walk in there with my capture hardware to capture that server, right? Especially since it will be in some kind of virtual environment and they will not allow me to go to the hypervisor and capture them. So there are sometimes limitations that you can't capture where you want to. There are other situations where customers having problems with a service provided by somebody else and they wouldn't let you into their data center to capture at their server. So you can only capture on the client side. Yeah, that is something that you figure out as soon as you're talking about where are we going to capture. Sometimes you can't just help it and you need to do something that is less than optimal, but you don't have the option of going somewhere else. So typical capture locations are local system. Local system means you're capturing on the client, on the server, or somewhere in between on a device that is part of the packet path, so to speak. And that could be client, server, intermediate device, firewall, load balancer. So if somebody tells me, hey, I didn't capture on the client or on the server, but I captured on the firewall in between, that is still a local capture. Yeah, that is very important to know because if you're capturing on a local system, the precision is not that good. So it depends on what you need to do, what your problem is, and you need to be aware of the side effects that this can have. And I will show you a few of those. Then, there's a span port. Everybody knows this probably. It means telling a switch that you need a copy of data. And we'll look at that. And then there's network tabs. And if you can, of course, always go with the network tab. We will see a couple of problems with that kind of thing. First of all, you need to have one, and then you need to be allowed to put it in place, which can be a problem too. Because if you tell somebody, hey, I want to put in this tab and I need to disconnect your link for this, they're like, no, you're not going to. So this is something that can happen sometimes. Okay, let's take a look at local system. Jeff, yes?
So another thing about inserting the tab sometimes, by bringing down the link and then putting
So I can...
Not only disrupting normal traffic in the mode of trying to get a tap in, but again, you've stopped potentially the issue.
Let me repeat that really quick because that was just at the end. So Jeff just said if you put in a tap and then suddenly the problem disappears, that can have a number of reasons because, I mean, everybody who has inserted a tab into a link a couple of times knows that if you do that and it's a hot standby configuration, the link will fail over to the other link and maybe your problem is gone. Or if that does it, you insert a tab and the link fails over, your link is suddenly empty. There's no packets anymore. So you need to fail it back again. So, yeah. And Angelo?
Question from Zoom. Do you have any suggestions for Kubernetes environments?
Kubernetes environments, unfortunately, are the kind of things where you either capture the whole traffic of the physical box that the current container is running on, or you capture within the container if you can, or in the host of the container. Usually we'll have to go back to basically running TCP dump inside the environment itself, because I don't think we have a better way yet. It's not satisfactory, but that's usually the only thing that you can do, unfortunately. Okay, so local system capture, it's easy to set up, just install, right? In my other talk I showed you what happens if you are not allowed to install anything, then you can at least use for Windows systems at least, you can use the PacketMon tool to capture on a Windows 10 or higher system and then convert it to PickupNG. If you want to know how that works, take a look at the recording of my other talk, because I don't have time to show it here. Well, on Linux systems, usually you install TCP dump. You could also install Wireshark or Tshark or dumpcap, which are all tools in the Wireshark suite. Of course, it requires installation privileges. So you need to be administrator to do that, or root on a Linux-based system or a Unix-based system. The word of warning is, if somebody ever told you the packets never lie, that does not apply in this case, because the system will lie to you. The packets will lie to you. They will not be precise. Yeah? And that is very important to know. So if anybody ever tells you the packets never lie, you're like, sure they do. Because if you capture on your own system, if you install Wireshark on any system that created the packets and received the packets, that will be a lie in many aspects. Yeah, it's still, depending on what you want to troubleshoot, it's still good enough to do the troubleshooting. For example, if you need to see layer 7 information, or you want to see, hey, does this request go out and is it formatted in the right way and do I get a response back at all? It's fine, but timing, packet sizes, all of this, not that great. And that is because the system is doing things to the packet that you capture after you captured them, and it's not the same like what you see on the wire. And I will show you in a demo how that looks like. So let me check. This needs to, how can I hide this one? This is really annoying. Okay, demo traces, local capture. So I will increase the font size a bit. So if you take a look at this screen, can you see anything where you think, hey, this doesn't look too good? Well, I can scroll a little bit to the right, so. Well, from my point of view, there's a couple of things wrong with this trace. I don't know if you know this, but what's the minimum packet size allowed on the Ethernet? The minimum packet size is 64 bytes. So if we remove the checksum, which is 4 bytes, and most packet capture systems do not store the checksum, the Ethernet checksum, the frame check sequence, what's it called? we still need to have 60 bytes at least. What do we have here? 54. How's that even possible? That is possible because we captured on the local system sending this packet. It was picked up by a capture process. We can check which one it was easily by looking at the statistics, capture file properties, and it will tell us, well, unknown application. Okay, no, it doesn't. All right, so we don't know which system it was or what it was, but it's probably dumbcap. This 54 results because the packet was not having more bytes than this, and it needed to be padded with 0 bytes by the operating system or the network card before it gets sent out to the wire, but we picked it up before that happened. The reason for that is modern network cards do that to take some stress from the CPU, so the network card will add the padding before sending the packet out, but we captured it before that happened. Right? We captured the packet in the process of going from the CPU to the network card, and the padding is not there yet. The other thing, if you take a closer look, is TCP checksum incorrect. And they only happen for one side, for the sending side, for the one that we're capturing on, because once again, the TCP checksum is also calculated by the network card. It hasn't been set yet when we captured it, so it's incorrect. So if somebody gives you a trace where you see that one side has invalid packet sizes, very small packets, and a lot of checksum errors, only one side, then you know this was a local capture. Somebody captured on a system that created those packets and received packets. The other thing, if you scroll down a bit, I mean, if you know what the maximum packet size is, well, even if you're assuming jumbo frames, you will end with like 9,000 bytes or maybe even 16,000 bytes for a packet. That is the maximum that you can have. But take a look at this one. This is 64K. That is totally not valid for traveling over the network. So once again, this packet was sent to the network card. The network card does the segmentation, cutting it into smaller pieces and sending them out, but we already grabbed the packet before that happens. Yeah, so this trace is very much lying to us, quite a bit. Yeah, and very often there's questions like, hey, can we do anything to cut it into the pieces that they really were on the wire afterwards? No, we can't. Well, yes, we can, but we don't know what the timing is, because the timing would be, for this one, the big one here, we would have to set it all to the same timestamp. And that is not really what happened on the wire. Yeah? So this is not that great, and if you ever see something like this, it's kind of hard to do timing analysis or big packet problem analysis or something like this. So in some situations, this is just not good enough. Do you have a question, Angelo?
2 questions from Zoom.
Okay.
Are admin privileges necessary for running Packet Monitor on Windows?
Yes. As far as I remember, yes.
And the next one is, how do you tap aggregate links?
How do you tap aggregated links? So it's more than one link, which means you need to put in a tab in each single one of them. That can get really expensive soon or quickly, unless you have a small package version where you have multiple links that you can put in. And then you usually need to have something like an additional device that allows you to select which packets you want and merge them together. So we'll get to that when we do the tapping thing. But if you want to tap multiple links, well, your investment in hardware is going up. Yeah, because then you will need something like a packet broker, which is one of the things where you can select which inputs you want, merge them together and stuff like this. So that is that basically means you're doing a professional capture, and you need somebody to write the check to the vendor building those things. But it's the best way to capture if you can, of course. All right. Any questions still to this PCAP? Okay. Let's continue then. Okay, the next thing is SPAN, switch port analyzer. Fun fact, SPAN was not invented to allow packet captures. Span was invented to troubleshoot what the switch is doing. Yeah, so the first span ports that were created were made to troubleshoot the actual switch. But we're kind of abusing this kind of feature now and making the switch send us packets that we want. Okay, so SpanPort has the big advantage of it's a reasonable effort to set up. It requires admin access to the manageable switch. So if you have a switch that has no management interface, it can't do a SpanPort. If you're capturing on a switch where there is no SpanPort, you will see a lot of broadcast and maybe multicast and a couple of unicast packets, but it's not really good for troubleshooting. So you need to have admin access to a manageable switch. You also, and that is sometimes a problem, you need to have an unused port that you can plug your monitor device in, your capture device. I have been at customer sites where they're like, yeah, all ports are in use. And then you cannot connect your capture device. So we found somebody who was on occasion and disconnected him, and then I had a capture port. The problem with that is you need to remember to remove the span port afterwards, because otherwise when this guy returns from holiday, he will find out that he cannot communicate anymore, because the span port usually is output only, so no more communication possible. So also, the packets never lie may not apply in this case, because also a span port may give you wrong readings. And we will have a demo about this too later. So I have an animation for you that shows what happens if you don't have a span port. I'm not sure how well Zoom will translate this, because it's an animation that is not that smooth anyway. So for all of you here, you can probably see it. For those in Zoom, I'm not sure if you do, but I have something for you in that case, because I have written blog posts where all the animations are in there, so you can just watch them on the blog post, and the link will be at the end. All right, so if you don't have a span port, this is what happens. The client, for example, sends a packet, and the server sends a packet, and our packet capture device is like, what the hell is going on? Because it doesn't get anything, right? Switches work in a way that they know where the devices are, and they will just forward the packets to the ports where the devices are connected. There's one exception to that rule. If the switch doesn't know who you are, or doesn't know where the devices are, it doesn't know the MAC addresses, it will broadcast the packets in all directions, which is why you sometimes see unicast packets in a capture even though you don't have a span port, but only one. It gets broadcasted, the station that replies to it will be sending its packet in a unicast way to the sender, and then the switch knows both MAC addresses and you don't see anything anymore. Yeah, so that is the reason why you sometimes see unicast packets. But in general, the packet capture device is not really seeing that much. Okay, so with span, this is different now. And this is how it looks like. When the client is sending packets, and first of all, we need to configure the switch for this. So let's say we want to see what server 1 is getting and sending. So we configure that as a mirror port. Then we configure the one where the packet capture device is as a monitor port. And now, whenever the client sends a packet, the mirror port will send a copy to the packet capture device. Also for the ones coming from the server. And now we can see what's going on. So basically that is what happens if you configure a span port. You tell the switch, hey, I need a copy of this incoming and outgoing port, just send it to me, and that's why I said you need to have a spare port to connect your packet capture device. All right, that is the standard way. The advantages of span are you don't need additional hardware because you already have the switches, and in most businesses they are configurable. So you can easily configure the switch to give you a copy of the packet. Easy to set up because configuring that is quite straightforward. Most of the time, if you don't know how to do this, you will just Google for the switch that you have and look for monitor, mirror, or span port commands, and then you will get it. Some of them are also configurable over a web interface, and that is quite easy to do. So, the main advantage of this is it does not impact live traffic. You have a question? Yes? Okay, Angelo, can you use the microphone because it's hard to hear. Yeah, it's on.
Okay.
Yeah.
I'm wondering, have you seen instances where there are different hardware vendors would like the way how the port is being captured? Is there like a difference between hardware vendors and how accurate they are?
Yeah, there is a difference between hardware vendors because the implementation in the switches may be different. For example, if you get a very high-end Cisco switch of the 9000 series, the ASIC in there will do the packet span port feature in hardware. And it will do that in a very efficient way. If you have a less expensive switch, so to speak, you can run into the trouble of the switch vendor deciding that your span traffic is not that important and dropping packets when it gets into trouble. So yeah, the quality of the span port copy process is different by vendor and also by product line. So if you get less expensive switches, it's usually less precise. Yeah.
Thank you.
Sure. Okay. So we do not have an impact on live traffic because we don't need to disconnect anything to do this. And the main drawbacks of span are the switch decides when and which packets to forward to the monitor port. So if it gets into trouble because there's a lot of traffic going on, it will drop packets, and the first packets it will drop are usually the span port session. So if you're troubleshooting an overload situation where you're like, hey, I need to figure out why this is happening when we have high load, it may be that you do not get the packets that you want because the switch is dropping them, even though they had been there, and you don't get them on the capture device. So that is something you need to keep in mind. Span ports can be a problem in high load situations. Also, yeah, even on a Cisco switch. The other thing, and that is the main reason why this happens also on a Cisco switch, is span ports may not be able to handle full duplex ports on greater than 50% utilization. The question is, why is that? And it's an easy thing to explain, I think. If you have, for example, a 1 gigabit link, it's full duplex, which means it has 1 gigabit receive and 1 gigabit transmit, which means in reality, even though we call it a 1 gigabit port, it's a 2 gigabit port. 1 gigabit for receiving, 1 gigabit for sending. If you're spanning or mirroring all the traffic to a output port, the only thing we can use on that output port is the sending direction to the capture device. We can't use the gigabit for the incoming traffic because there's nothing incoming. So we need to send 2 gigabit of potential traffic volume to a 1 gigabit port. And that will make the switch drop random numbers of packets, which is kind of a rare situation because very often you're using span ports on single systems and they're not communicating full speed in both directions all the time, but it's something you need to keep in mind. And if that is a problem, you could try to, for example, span a gigabit port to a 10 gigabit output port, because a 10 gigabit output port will have no trouble outputting 2 gigabits of traffic from the 1 gigabit full duplex port. But then you need a capture device that is capable of handling at least 2 gigabytes of traffic, and you need to have a capture device that has a 10 gig interface, which means your laptop is probably not going to work. That being said, there are 10 gig capture cards for laptops now. You can connect them to your Thunderbolt port and you have 10 gig interfaces on your laptop. Those are not that cheap. I think I've seen them for $250 or something, but I mean, if you need to capture 10 gig links, why not? Yeah, I've seen them on Amazon, so you should be able to find them too. All right, so next demo, span ports. Let's take a look at span port things. This is something that you could easily see if you're doing span ports. If you're taking a look at this PCAP file, and I'm one of the persons who are scrolling through PCAPs, you will see that there's a lot of red in there. By the way, if you like the way my Wireshark is colorizing packets, you can find my color scheme on my color rules on my blog. The blog link will be at the end. So there's tons of retransmissions, there's tons of other things out of orders. Like if you're looking at this kind of trace, you'd be like, uh-oh, something is really, really broken here. Okay, so to be honest with you, no, there isn't. It's just that the span port that was configured here creates packets that shouldn't be there. And the reason for that is that very often people, if they are capturing something, decide to capture more than one system at the same time. And this can result in this kind of thing. And I have another animation that will show you why. And let's see if we can take a look at that one. So if you're doing a multi-source span, for example, you have like configured a mirror port on 2 servers at the same time. Now, what happens if the client is talking to a server? You get 1 copy of the packets each, which is totally fine. But what happens if server 1 and server 2 talk to each other? This is what will happen. You see a packet from server 1, it's getting copied, arriving at server 2. And when it arrives at the mirror port of server 2, you get another copy. It was a little slow on this, maybe it's faster now. So it moves in there, gets a copy, moves to the other port, gets another copy, and you have duplicates in your trace file. So you see every packet twice. And as you have seen, that messes up the TCP expert in Wireshark because it thinks, hey, I've seen a packet twice, this is a retransmission. Is it a retransmission? No, it's just a capture error. Yeah, so this is important to keep in mind. The problem with this kind of thing is, if you take a look at the packets, and we can go to the first one, for example, take a look at this one. What's the difference to the duplicate? What is different? If we take a look at the second one, which is a duplicate of the first one, we click on it, and is there any difference? I mean, what I've done a lot of times if I'm checking if there's duplicates in a PCAP is I use the one, I go to the first one, and then I go to the second one, and I just go up and down with my cursor keys and take a look at the hex bytes. What's different? It's identical. So can you filter on anything to separate the duplicates from the originals? No, because they're identical. Any filter that you use in Wireshark to find out who's a duplicate and who isn't won't work, but it will match both. Yeah, so you can't remove duplicates in Wireshark. It's not possible. If you have them like this and just Wireshark, you're in trouble because now you need to analyze something where all the duplicates will mess up your results. So the way to do this, let me show you, is there's something called edit cap. I need to make this bigger so that you can see. Come on, come on, come on. Okay, let's go to the demo traces folder. There's my span trace. There's something called edit cap. It's part of the Wireshark installation. So if you install Wireshark, you also get edit cap, and I can recommend you add the Wireshark path to your search path so that you can use edit cap wherever you want to. And in here, there's an option to do duplicate packet removal. This. And let's just do that. So edit cap -d or -d span. And we write it to span deduplicated. Okay, what did I do wrong? Interesting. Span isn't a decimal number. I need to take a look at the options again. What's going on? Infile, outfile. That should work. I rename my span to something more useful, span.pcap. Maybe it's that. Oh, okay, it's just that it can't access it. again. Now edit cap, minus D, span, deduplicated. What's going on? Did they change any kind of options again? I need to use lowercase d. The uppercase D is for specifying the window. Okay, like this. Sorry. So it will tell me it saw 15,238 packets and 7,359 were skipped with a duplicate window of 5 packets, which means it's going back, or it's considering 5 packets in a rolling window, and it looks at each packet and checks if it has the same, if it's the same like the past 5. Sometimes duplicates are further apart than that. They appear a lot further apart. So that is when I can do, let's say, uppercase D 50, like look into the past for the last 50 packets to see if it's duplicate. Let's see if that changes anything. Yeah, you can tell that now we have 210 packets more being skipped because of being duplicates. I think you can probably increase it to 150. Yeah, it stays like this. So the interesting thing now is if we use Wireshark to open the span deduplicated one, the whole story changes completely. Yeah, you can tell now, hey, it's not so bad, right? Everything was red before, now this looks pretty good. So this is something where a seasoned network engineer at my former company came to me and showed me the trace of with all these duplicates in there, and he's like, our network is completely broken. I'm like, no, you just captured it on multiple ports in a span situation and we need to deduplicate it. And suddenly it turned out everything was fine. But he was completely freaking out, and he was a senior network engineer. So I was like, oh, wait, I show you something cool. And we did this, and then he was like, good. Yeah, all right, so this is something you need to keep in mind if you're using span ports, and using span ports is very, very common. So multi-source span is something where this happens. This also means spanning VLANs, because if you're spanning VLANs, then this also happens. Except, and that is something where I'm going into in the next slide, if you have created duplicate packets, they are hard to avoid. The only thing is you could set your VLAN span to send or receive only, meaning you only copy the send direction or the receive direction, which reduces the copies, of course. But that gets bad as soon as somebody is sending data into the VLAN, and you need to have both directions again. So I would probably prefer to deduplicate afterwards. Grab everything you can, deduplicate it. Edit cap is quite fast doing that. Okay. And I should correct the slide because it's not uppercase D, it's lowercase d. All right, so I did that demo already. Now, tabs are the most exact way to capture things. By the way, tab, meaning test access point, is some sort of a lie too, because they were called tabs and then somebody found a meaning for this acronym. So it's called terminal access point or test access point, but in fact it's just a tab. Yeah, it came from phone tab, wire tab, and calling it a test access point, nobody does that. Except if you're writing slide, then you're writing test access point somewhere, probably. Okay, so a tab has some effort to set up because it means that you need to figure out what kind of tab you need. If you ever try to buy a tab and you go to any of the tab vendors, you will see that there's so many options to choose from and so many decisions to make that it can be a little bit intimidating. You need to find out, hey, do I want to insert this into a copper link? Do I want to insert this into a fiber link? Will it have to be a breakout tab, meaning I need a separate breakout or separate link for send and receive? Or do I want the tab to aggregate the packets for me, just like a span port does? If you're going for fiber tab, also often called splitters, you need to figure out what split ratio do you want. Because splitters are taking away some of the light of the original connection, And each splitter will have, or each fiber tab will have a split ratio. And the split ratio will tell you how much of the light will stay on the production link and how much will be diverted to your capture device. And common ratios are 70-30, so 70% light for the production link and 30 for your capture device, or even 50-50. I've seen people use 90-10 links, like 90% staying on the production link because they were afraid that production would go down. Yeah, and the 10% weren't enough for the capture device to see anything. It was too weak for the capture card to actually detect the signal. So it's something that you need to choose carefully. And my advice always is, if you're interested in buying a tab, talk to the vendor. Tell them what you want to do. Tell them what you're planning. And they will figure out together with you what would be best for you. So in my opinion, or in my experience, they usually know their stuff really well, and they will help you figuring out which one you need. The other thing is finding the correct physical location. Sometimes that could be a problem. For example, when I worked at Airbus, I wasn't allowed to go into the data center because I had no data center clearance. The only people allowed in there were the guys who are allowed to put in servers, do all the cabling work and that kind of thing. And telling them to put a tab in is really a tough task because you need to specify exactly where you need it. And if you've ever stood in front of a server that has like 10 or 15 ports, figuring out which one you want to tap is quite an adventure. It can go wrong a couple of times before it goes right. So yeah, it requires having an additional device, a tab, to insert into the link. And you need to disconnect the link, of course, because you need to insert the device. And I'm saying here that it needs 1 or 2 link disconnects because sometimes you need to remove the device after you captured or after you figured out what the problem is. So you have another link disconnect. And in the past, when I was working primarily in network troubleshooting, we often sold tabs to customers because when it was time to remove them, they were like, can't we let it in there? Because it's in there and we don't want to have another disconnect. How much is it? So my tabs changed regularly because I had to buy new ones all the time, invoicing the customer for the old ones that I let in their network. But their advantage was now they had a tab at a place that could be useful in the future. So very often it's a good idea, if you have any say in this, to tell people to put in tabs before they actually run networks so that they have points where they can access their data. Question?
So you feel like it's acceptable or maybe good practice, just go ahead and throw that tab in if you're doing greenfield?
Yeah. So the question is it acceptable to just add tabs in locations where you think they could be useful? Yes. It's a question of how much money you can spend. But if I take a look at all the expensive devices that get put into data centers, tabs are usually, you won't even notice them on the invoice. Especially if you're using the one link small thingies, not the big ones. But if you're using small tabs, it's like a footnote on the bill, probably. Yeah. So if you can do that, do it. I had one customer once after troubleshooting where we did something like this, and the boss said, well, here's like 100,000 euros, go and get as many tabs as you need, put them in, I want to have them in place for the next time. Yeah, that is a smart kind of move. And of course the tab vendors are very happy if you do that. Yeah. Okay. If I have experience with copper tabs, yes, quite a lot. The copper tabs are different from fiber tabs because they do need to do link synchronization, especially above 100 megabits. There are passive tabs that you can buy that are really cheap, like the throwing star and other things like this. They're completely passive, but they only work until 100 megabit, not above, because gigabit is electrically different. And it needs to be negotiation. It needs to do negotiation with both link sides when it gets inserted. So that is one of the things where you can talk to a tab vendor. How fast will the link come back up when I insert your tab? And they are tweaking that all the time to make it as fast as possible. I was thinking about having a competition like this at SharkFest, like putting a tab there and having people try to connect the tap as fast as possible, and having a constant ping running and seeing who can do it the fastest without losing the least pings. Maybe I do that in the future somewhere. So yeah, copper taps are the most common ones, but if I can, I prefer to tap in fiber because they don't need power. Copper taps always need power because they act like a electrical device in your network. All right? So if you're having a tap, then the packets never lie is mostly true. Yeah, it's quite hard to argue against a tap capture, for example, in court, if you have to, because those devices are made for high precision captures. Yeah, they're giving you the best results you can. It's mostly true because there are some tap models that are having sort of the same problem like a span port, the so-called aggregation taps, which aggregate the two receive and transmit links into a single output link because you want to use them with your laptop. They can drop packets if the utilization goes above 50%. And once again, if you need to do this, there's also special taps that can get around that problem. For example, ProfiTap has a tap that connects to USB 3, which has a 6 gigabit speed, I think. So if you have a 1 gig tap with a USB connection, then there's no problem with the 2 gigabit total traffic that you see. Okay, so Breakout Tab, this would be the very basic, very precise tab. And what it does is, and once again, this is an animation, it gets put into the link, so you need to disconnect it. Then you have a capture device. The capture device gets two links from the tab, one for the receive direction, one for the transmit direction. So when packets travel, they get copied to the according links. Once again, if you want to see this animation again, just go to my blog. It's running there forever, probably, as long as the blog is online. Basically, yeah, you have one output link to the capture device for both data directions or packet directions, which is also a problem in itself because now you need a capture device with a dual port network card. And that gives you a whole different sort of problems, which I have written about in my blog, because you need to have a capture card that is synchronized and can receive the packets in the correct order. Yeah, sometimes you get out of order arrivals. Otherwise, if you're using two single network cards, which you could do, the timings are sometimes not correct. So to battle that problem, aggregation tabs can be used. You will notice that they're inserted just the same, but they have only one output link, and packets that travel get outputted on the same link. And in this case, if you have a high utilization over 50%, of course, the tab has to buffer and then drop packets. If it buffers. Some don't buffer, they just drop packets. I had some trouble with aggregation tabs in the past, but these days they seem to work much better. All right, so important to know, and that is something out of the security realm, so to speak. Tabs usually have a one-way feature, which means that if the capture device is trying to send anything into the network, it gets discarded. This is once again an animation. So if we see that the capture device is trying to send packets into the network, well, it arrives at the tab and then gets killed. This is very important because you don't want to send data from your analyzer into the live network. So having a tab usually means it won't let that happen. Because on span ports, there's supposedly the same thing happening. So a span port should drop incoming packets from the mirror port, but some don't. And then if you connect your device, you are sending packets into the live network, and that is not a good thing. So with a tab, this is something really useful and very often means that you can deploy tabs in different security zones and capture them with the same capture device if it has multiple cards without compromising the integrity of the different security zones. All right, the main drawbacks of tabs: you need additional hardware, which means you need to buy stuff. Secret tip on my part here is you can buy really old tabs from vendors that don't exist anymore on eBay for cheap. So you can hunt them there. but they're usually not that up to date. But sometimes there are some that you can really use, and you get them for like 10 to 50 bucks, which is a fraction of the price if you buy them new. But yeah. Okay, permanent tabs require 1 tab per link. This is some sort of the answer for the multi-link aggregation thing. You need to tab all of them. Temporary tab usage means frequent disconnects. You need to remove them all the time. That is not fun. And precision may degrade for aggregation tabs. So if you use those, well, sometimes you need to know what your limits are. Okay, conclusion. You need to determine a capture strategy. Do you need a tab? So when do I need a tab? Well, I need a tab if I'm in serious trouble and I have timing issues, I have overload issues, I need to avoid span ports or local captures. For example, if you see that there's packet loss, it could be that the switch is dropping packets and a span port will also not contain the packet even though it was there. So if I need to prove that a packet actually traveled from a switch to a server, the only thing I can do this is with a tab. Because if I put the tab into the link and I see the packet on my capture, then I know it was on the link. And I had situations in the past where servers discarded packets that were definitely incoming. This is really hard to troubleshoot otherwise. You need a tab for that kind of thing. Is span available? For example, if you have non-manageable switches, you don't have span, right? So that is another problem. Can you live with local capture results? Well, if you're just trying to prove that there's data coming in and going out, local captures are fine. But if you need to do timings, packet sizes, all of this, you can't go that way. Okay, for tap and span, plan carefully. Don't go in there like, hey, we're going to capture and I'll do this on the fly, because that will fail. Sorry. And you should always test, which means if you have the setup running, capture and look at the data if they match your expectations. I have been on so many customer sites where somebody configured the span port for me, and when I looked at the data, he had spanned something that I wasn't interested in. He took the wrong source port, whatever. And also, sometimes, especially for fiber tabs, you can insert them in the wrong direction. So you will see that the production link is working, but you're getting no light on the tab. Because the tab is using a sort of like a, you can imagine like a mirror system, and if the light is coming from the back of the mirror, it will still go through, but it won't be diverted to your capture device. Which means you can insert fiber tabs and having production link still work, but you won't see anything on your capture device. So if you're doing a long-term capture, make sure that what you need is actually going to end up in the device, because otherwise you return after a week and find out that you captured for, yeah, it was futile to capture in the first place. All right, so if you want to know more, and I could go into a lot more detail than this talk, I have a blog that has the so-called network packet capture playbook. It has right now, I think, 6 articles or 6 postings. I will need to do more, but I didn't have time in the past 2 or 3 years. And also Tony wrote about where to start, and it's maybe a little more beginner-friendly than my blog post, because my blog post is very, I think, technically condensed and not that beginner-friendly. So if you want to know more about how to capture packets, those are the 2 that I would recommend. And if you have any more questions, just ask me. I'm always happy to help. You can email me. You can also direct message me on Twitter, and I will help as much as I can whenever you have anything. Okay, how are we doing time-wise?
5 minutes.
5 minutes. So, any questions?
One question on Zoom from Trevor. What is the difference between a tap and an NPB?
The difference between a tab and?
NPB.
Okay, I need to take a look at the chat, I think. Network packet broker, okay, yeah. Well, the tab is the device that actually gets the data from the wire into the direction of a packet broker or a capture device. A packet broker is like a configurable device where you can have input links where data from tabs is coming in, and output links where your capture devices are, and you can mix and match packets that are coming in, for example. Let's say you have like a link or a connection that consists of 4 10 gigabit links. 4 10 gigabit links means you have the potential traffic of 40 gigabits times 2, because it goes in both directions, which means 80 gigabits, that's quite a lot. Maybe you're only interested in one VLAN on that link. So what you do, you insert a tab into all of these links, so it's 4 10 gigabit tabs, and output the traffic of the tabs into a packet broker. So you need 4 input ports on the packet broker. And on the packet broker, you create a filter saying, hey, from these 4 links, please only give me VLAN number whatever, and output it to my 1 gigabit link where my capture device is. And that is what a packet broker does. It allows you to manage a lot of sources where packets are coming from, tapped packets usually, and output them to 1 or more capture devices. Yeah, this is also the way how, if you want to capture like 400 gigs or something, or 400 gigabit ports, no single capture device is capable of doing that, and you need a packet broker to split them into, by various criteria, into manageable sizes, and yeah, that way you can capture more than what a single device could handle. So packet brokers are quite useful, but you need to configure them, and they're sometimes not that easy to understand at first. All right, any more questions? No. All right. Then thank you, and I hope you found it useful. I think we're doing feedbacks later, right, Angelo? Okay. Once again, if you need to know more, just let me know. There's the chat again. Sure, you're welcome. And yeah, good luck with your capturings, and thanks for joining us virtually. We're always happy to have you here. I hope it was a good experience, and maybe the animations did work, but if they didn't, just take a look at the blog again, and they can see them. I'll go back to that slide for a bit so that, come on. So here's the links again in case you need them. Okay, that's it. Thank you.